We've always thought that the hardest substance on Earth is diamond, and it really is incredibly useful and performs miracles. It cools expensive electronics, cuts through the toughest materials, and withstands extreme temperatures. But even diamond has many weaknesses. A natural diamond can crack if hit in certain directions, and most importantly, these precious stones are extremely rare and expensive. That was true until today. In 2025, Chinese scientists finally managed to create a super material much harder than diamond. Imagine tank and aircraft armor that no shell or shrapnel can penetrate, knives and cutting tools that never dull, even after decades of use, trains racing at extreme speeds without any wheel wear, and spacecraft that can easily travel to Venus, surviving its crushing pressure and heat, and soon journeys to the most distant planets will become a reality for humans. Sounds like science fiction? But this is already real. And today you'll learn not only how dreams from sci-fi movies are becoming reality thanks to this technology, but also how it will soon change every one of our lives. China has managed to create not just a very hard stone, it's an entirely new form of carbon with a different crystal structure. If a normal diamond is built like Lego blocks, forming neat cubes, this new material, lonsdaleite, has a hexagonal structure like a honeycomb. And it's exactly this pattern that makes it an absolute powerhouse of strength. But here's the interesting part. This material was first discovered back in 1967 in a meteorite that fell in Arizona. For 60 years, scientists argued, does it really exist as a separate substance? Or is it just a defective, ordinary diamond? Some laboratories said yes, others said no. There were scandals, retractions, scientific battles, but none of the world's top researchers could get any practical use from this incredible find. And suddenly, in 2025, Chinese scientists from Jilin University and Sun Yat-sen University put a bold end to the argument. They didn't just prove that lonsdaleite exists, they learned how to make it. Crystals up to 1.5 millimeters in size, big enough to be seriously tested. And the results shocked even the researchers themselves. Hardness up to 155 gigapascals. Like having an elephant stand on the tip of a needle and the needle doesn't break. That's 40% harder than natural diamond. The material stays stable at temperatures up to 1,100 degrees Celsius, far hotter than volcanic lava. But the most incredible thing isn't even its hardness. This material has another property that will soon completely change all our technology. Your laptop heats up, the processor slows down, the fan roars like a jet engine. A gaming PC the size of a refrigerator, half of it is cooling systems. Google's data centers consume as much energy as a small country, and a third of that goes just to air conditioning. Now imagine, diamond heat sinks turning heat from an enemy into an ally. A computer runs at full power and stays cold as ice. A supercomputer fits easily into a suitcase. Data centers become 3 times more efficient. Diamond conducts heat 5 times better than copper, like the difference between a garden hose and a fire hydrant. But until recently, this was just a beautiful theory. Diamonds were very expensive, there were very few of them, and making anything practical out of them was impossible. Now everything changes. At the same time as the Chinese breakthrough, a quiet revolution happened in South Korea. A team led by Rodney Ruff at the Institute for Basic Science did what seemed impossible. They learned how to grow diamonds almost like mushrooms after rain. In the past, making a synthetic diamond required a press the size of a house, pressure like at the bottom of the Mariana Trench, temperature like at the Earth's core, and weeks of waiting. One small synthetic crystal would cost as much as a car. The newest Korean method is almost like magic. A liquid alloy of gallium, iron, nickel, and silicon in a regular furnace. Add methane and hydrogen, and diamond films start to grow on the surface of the liquid metal. The first crystals appear in just 15 minutes, and a continuous film forms in 2.5 hours. Imagine, before a synthetic diamond was born like a royal heir, slowly, expensively, one at a time. Now it can be printed like a newspaper, fast, cheap, and in bulk. This isn't just speeding up. It's like trading in an old horse for a jet plane. These incredible discoveries have already pushed all leading nations into a new technological race. The United States is spending billions on diamond-based sensors capable of detecting any enemy equipment from enormous distances. Japan has strictly classified its research on perfect diamond wafers for building next-generation supercomputers. In Russia, rumors suggest they are testing diamond coatings for hypersonic missiles. Why so much secrecy? Because whoever first learns to mass-produce diamond components cheaply will gain technological superiority for decades. It's like the invention of gunpowder or the steam engine, an advantage that simply cannot be ignored. And while politicians keep waging endless trade wars, the real battle is being fought in scientific laboratories. An Abrams tank weighs 70 tons. Half of that weight is armor, and yet it still has plenty of weak points. Optics, glass, targeting systems. One well-placed shot and a multi-million-dollar machine instantly becomes scrap metal. Composite armor with diamond layers is 3 times lighter than steel, but can stop a projectile that would pierce standard armor clean through. Diamond bulletproof glass doesn't fog in sandstorms and doesn't crack from extreme temperature changes. Optical systems continue working in conditions where normal equipment would be blind within minutes. Imagine a fighter jet with no weak spots at all, or a submarine capable of operating at depths where pressure would crush any conventional hull. Military applications for this super diamond are impressive, but the real wonders await us in civilian life. Every high-speed train in Japan undergoes long maintenance every 10 days, checking wheels, rails, bearings. At speeds of 400 kilometers per hour, wear and tear is simply brutal. Because of this, every kilometer of track costs millions. Diamond coatings on critical components could turn a train into a virtually maintenance-free system. Speed could be increased to 600 kilometers per hour, and yet the rails and wheels would wear down even more slowly than before, at 300 kilometers per hour. Maintenance could drop to just twice a year. In aviation, it's even more dramatic. Turbine blades with diamond coatings are unaffected by sand, dust, or birds. An engine could run in the Sahara as reliably as in Switzerland. Lifespan increases several times, but the key is reliability, which means planes would never again crash due to engine failure. Here's a story that will impress anyone who has ever worked with their hands. A standard metal drill bit dulls in just a few hours of use. Add a diamond coating, and the same bit works for months. A drilling crown for oil wells used to last a week. Now it could work for half a year. A mining company used to spend millions of dollars annually just replacing cutting tools. Equipment downtime amounted to dozens of hours per month. Drill bits and crowns with diamond coatings can cut through kilometers of solid rock without dulling. Breakdowns become rare. Downtime drops to just a few hours a year. The savings are enormous. Hundreds of millions of dollars annually for each large company. But all of this pales compared to what diamond technology promises for space. The Soviet Venera 13 lander survived on Venus's surface for a record 127 minutes. The temperature was 465 degrees Celsius with pressure like being a kilometer under the ocean. Any Earth-made machine dies there within hours. Diamond panels, instrument windows, and heat sinks could operate in Venus's hell for several weeks. Instead of a quick selfie before inevitable death in the all-consuming flames of Venus, it would be possible to conduct full-scale research on the scorching planet and return to Earth. Mercury, where one side is heated to 400 degrees and the other is frozen to minus 170, would also be within operational range for diamond-based technology. The moons of Jupiter, where radiation would kill a human in seconds. Diamond shielding turns that lethal zone into a normal working environment, and this opens up space travel possibilities so breathtaking it's hard to even imagine. While we admire public achievements, behind closed doors, a real tech race is underway. Lockheed Martin is testing diamond nose cones for hypersonic vehicles. Boeing is experimenting with diamond coatings for space probes. And what's going on inside SpaceX's labs? We can only guess. In Russia, several research institutes are working on diamond optics for military satellites. In China, entire factories are being built to produce diamond components, officially for industrial use. In Israel, diamond sensors are being developed that can detect a terrorist tunnel a kilometer underground. Every country understands. Whoever first puts diamond technology into mass production will have the upper hand in everything, from electronics to space. A regular iPhone heats up heavily under intense use. Its processor slows down and the battery drains faster. A gaming laptop weighs 3 kilograms, with half that weight being its cooling system. Diamond heat sinks as thin as a human hair turn a smartphone into an always-cool machine. The processor can run at full power non-stop, the battery lasts longer, and the case stays cool even during the heaviest tasks. Modern data centers and AI servers have become true energy eaters. Google, Microsoft, and OpenAI spend billions of dollars just to cool their supercomputers. Half of all the energy they consume goes not to computation, but to air conditioning and cooling systems. Diamond heat sinks can cut these massive costs by a factor of 3. And here is where true science fiction becomes reality. Scientists have recently learned how to create tiny defects in synthetic diamonds. They simply replace one carbon atom with nitrogen and leave an empty spot next to it. This produces a quantum sensor just a few atoms in size. In the past, to measure a very weak magnetic field, you needed a lab the size of a room, liquid nitrogen for cooling, and equipment costing millions of dollars. Now a diamond chip the size of a fingernail does the same job for $120. What does this mean? Medical devices that can see the activity of the brain and heart without touching the body. Geological detectors that can locate mineral deposits kilometers underground. Navigation systems that work in underground tunnels and underwater, where GPS is completely useless. In medicine, the latest diamond technologies are also performing miracles. A standard surgical scalpel becomes dull after just a few operations. An MRI scanner the size of a room produces blurry images if the patient moves even slightly, and titanium implants last only 10 to 15 years before needing replacement. Diamond blades cut tissue cleaner than any steel knife and stay sharp for years. Diamond components in MRI scanners produce images of incredible clarity, allowing processes to be seen at the level of individual cells. Diamond-coated implants are biocompatible and last for decades without rejection. In deserts, solar panels get covered with sand and dust within a year, reducing their efficiency by a third. Diamond coatings solve the problem completely. Sand and dust simply slide off the panels without leaving a single scratch. Wind turbine blades with diamond coatings can withstand hail, sandstorms, and salt spray. At nuclear power plants, diamond radiation detectors are critically needed for safety, working for decades without replacement or recalibration. Let's break it down. What is already in use and what is still in the planning stage? Diamond heat sinks are already installed in military electronics, in places where regular cooling can't keep up. In high-powered lasers and 5G base stations, they prevent overheating. Cutting tools with diamond coatings have been used in industry for several years, drilling and cutting without dulling for months. Quantum sensors on diamond chips are already working in scientific laboratories all over the world. In the next 2 to 3 years, diamond plates will appear in all our smartphones and laptops. The Korean method of fast-growing diamonds has made them far more affordable. All electronic gadgets will soon become much more powerful, lighter, and capable of working for years without breakdowns or slowdowns. Composite armor with diamond layers is already being tested on military vehicles. In 5 to 7 years, it will be the turn of large diamond panels for spacecraft and mass coatings for trains and airplanes. Entirely diamond car bodies remain a dream for now, but scientists will likely solve this problem within the next 10 years. And here's the most amazing part. All of this is happening at the same time. Several breakthroughs are merging into one powerful wave. China's ultra-hard diamonds, Korea's rapid diamond growing method, plus enormous demand for new technologies in electronics and space. When that happens, a true technological avalanche begins. Better cooling makes electronics more powerful. More powerful electronics open up new possibilities. Stronger materials make production cheaper. It all works like dominoes. One thing sets off the next. And the key point is, this is happening right now. Every week brings new developments, companies, and contracts. What was recently science fiction is becoming ordinary technology right before our eyes. Your next smartphone will work faster and longer because it won't overheat. Cars will become far more reliable. Diamond coatings on critical parts will extend their lifespan many times over. Medical diagnostics will become more accurate. Devices with diamond sensors will see what was previously invisible. Public transportation will become faster and quieter. Airplanes, safer and more economical. Deep space missions, far more ambitious and productive. And military equipment will become almost invulnerable. But the biggest winners are all of us, because better materials mean better technology, and better technology means a better life. Diamond technology is opening space in ways we never dreamed of. Probes with diamond shielding will be able to fly much closer to the sun, into zones where any other equipment would simply melt. On Jupiter's moons, where radiation kills electronics in hours, diamond-based craft will operate for years. Martian rovers will survive dust storms that destroyed all previous missions. Such indestructible robots will work on Mars for years without breakdowns, preparing the entire foundation for future human expeditions. On the moon, we will be able to build bases from materials immune to cosmic cold, meteorite strikes, and wild temperature swings. And the most fantastic possibility, flights to other stars. With diamond shielding, a spaceship could travel for decades without breaking down. Humanity will finally gain the ability to reach other habitable worlds. In our time, diamond is no longer the limit of hardness and strength. Now it's just the starting point. China's ultra-hard diamonds, Korean technologies, and quantum sensors will soon change our world beyond recognition. We stand on the threshold of an era where machines no longer break, electronics never overheat, and space travel becomes as ordinary as air travel is today. The diamond revolution has already begun, and very soon it will change the life of every one of us.